Imagine a world on the brink of a revolution so profound it could rewrite the very fabric of reality. A world where machines think faster than light, where the mysteries of the cosmos unravel in a heartbeat, and where the line between human and artificial consciousness blurs into a chilling unknown. Welcome to the dawn of quantum computing, a seismic shift in human history that's shaking the foundations of science, technology, and even our understanding of the universe. But hold on tight, because this story isn't just about circuits and code. It's about a heart-stopping moment when the world's most advanced quantum machine was shut down in a flash of panic, and a world-renowned scientist, Michio Kaku, stepped into the spotlight with revelations so staggering they left the global scientific community reeling. What caused this abrupt halt? What secrets did Kaku unveil about extraterrestrial intelligence and the dawn of artificial consciousness? Buckle up as we dive into a tale that's equal parts thrilling, unsettling, and awe-inspiring. A journey into the unknown that will leave you questioning everything you thought you knew. Picture this: the 21st century, a whirlwind of innovation that's turned science fiction into reality. Artificial intelligence has woven itself into our lives, from smartphones that predict our every move to algorithms that seem to know us better than we know ourselves. But lurking in the shadows of this digital age is a technology so radical, so mind-bending, that it makes AI look like child's play. Quantum computing, a force so powerful it could crack the codes that guard our secrets, solve problems that defy comprehension, and maybe, just maybe, unlock the door to alien civilizations. But before we plunge into the cosmic unknown, let's rewind to a moment that sent shockwaves through the scientific world. A cutting-edge quantum computer, hailed as the future of technology, was suddenly powered down, its humming circuits silenced by an urgent, undisclosed crisis. Whispers of danger rippled through labs and government halls. Was it a glitch? A security breach? Or something far more sinister? And then, like a bolt from the heavens, Michio Kaku, the legendary theoretical physicist, took center stage. In a gripping interview, his voice trembling with emotion, Kaku revealed truths so startling they seemed ripped from the pages of a sci-fi epic. He spoke of quantum machines pushing the boundaries of reality, of extraterrestrial signals hidden in the stars, and of a future where artificial minds might outthink humanity itself. The world stopped and listened, spellbound. Who is Michio Kaku, you ask? He's no ordinary scientist. A visionary with a knack for making the impossible feel within reach, Kaku is a rock star of physics, a professor at the City College of New York, and a co-founder of string field theory, a mind-bending framework that seeks to unite the laws of the universe. His books, like Quantum Supremacy, have electrified millions, painting a future where quantum computers don't just compute, they reshape existence. Kaku's words carry weight, and when he speaks of quantum breakthroughs or alien intelligence, the world hangs on his every syllable. But this time, his message was different. It was urgent, almost haunted, as he hinted at discoveries so profound they could change everything. What did he know? And why was this quantum juggernaut shut down? To understand the stakes, let's peel back the curtain on quantum computing itself. Forget everything you know about computers, those clunky boxes of ones and zeros that power our world. Quantum computers are a different beast entirely, built on the strange, almost magical rules of quantum mechanics. Back in the early 1900s, pioneers like Max Planck and Albert Einstein cracked open the secrets of the subatomic world, revealing a reality where particles dance in multiple states at once, defying logic. This was quantum theory, the spark that would one day ignite a computing revolution. Fast forward to 1980, when physicist Paul Benioff dared to dream of machines that harnessed these bizarre quantum laws. He proposed using phenomena like superposition, where particles exist in multiple states simultaneously, and entanglement, where particles become so intertwined that one state instantly affects another, no matter the distance. These weren't just theories, they were the seeds of a new era. In 1982, Richard Feynman, a titan of physics, took it further, envisioning computers that could tackle problems so complex they'd leave classical machines choking in the dust. His vision was radical. Quantum computers wouldn't just be faster, they'd be a new species of technology. The real thunderclap came in 1994, when Peter Shor unveiled an algorithm that sent chills down the spines of cryptographers worldwide. Shor's formula proved quantum computers could crack encryption codes that protect everything from bank accounts to national secrets, doing in seconds what would take supercomputers centuries. The world took notice. By 1998, researchers like Isaac Chuang and Neil Gershenfeld built a rudimentary 2-qubit quantum computer at Los Alamos, a proof of concept that lit a fire under the scientific community. Sure, it was basic, just 2 quantum bits, or qubits, compared to the thousands needed for real power, but it was a glimpse of the future. Qubits, unlike classical bits, aren't limited to ones or zeros. Thanks to superposition, they can be both at once, juggling countless possibilities in a single calculation. Add entanglement, and you've got qubits working in sync across vast distances, creating a computational symphony that defies imagination. By 2010, Chinese scientists pushed the envelope further, achieving quantum teleportation, transferring a particle state over 10 meters without moving it physically. It was a feat straight out of Star Trek, hinting at a future where quantum networks could replace the internet. Then came the game changer. In 2013, Google and NASA teamed up to unleash the D-Wave quantum computer, a beast stationed at NASA's Ames Research Center. This wasn't just a machine, it was a glimpse into the impossible. Hartmut Neven, Google's engineering director, called it a breakthrough for machine learning, capable of solving problems 10,000 times faster than classical computers. From curing diseases to exploring distant planets, the D-Wave's potential seemed limitless. Some even whispered it could help detect alien life. Why? Because a bold new theory was circulating among astrophysicists. Black holes, those cosmic enigmas, might act as natural quantum computers, storing information in ways we're only beginning to grasp. If advanced alien civilizations were using black holes as computational hubs, a machine like D-Wave might pick up their signals. The idea was intoxicating, a bridge between science and the stars. But then, disaster struck. The D-Wave project was shut down, its promise snuffed out by government orders. The reason? Fear. Quantum computers, with their ability to shred encryption, posed a threat too great to ignore. Imagine a safe holding billions in assets, its lock unbreakable by any supercomputer. A quantum machine could crack it in seconds. The implications were terrifying: cyber attacks, data breaches, chaos on a global scale. The decision was made: pause the quantum race before it spiraled out of control. Yet Google pressed on, and in 2019, their Sycamore processor achieved quantum supremacy, solving a problem in 200 seconds that would take the world's fastest supercomputer 10,000 years. The world gasped. IBM followed in 2020 with the IBM Q, the first quantum computer built for commercial use, opening the door for businesses and innovators to tap into this cosmic power. Suddenly, quantum computing wasn't just for labs, it was for the world. Now, let's zoom out to the stars. The Fermi paradox haunts astronomers. If the universe is teeming with life, where are the aliens? Kaku has a jaw-dropping theory. What if extraterrestrial civilizations are out there, but their technology is so advanced it's invisible to us? In a riveting interview, he proposed a hidden interstellar network, a cosmic superhighway woven through the fabric of space, allowing alien societies to travel undetected. Our radio telescopes, scanning for simple signals, might be like cavemen searching for Wi-Fi with a stone tablet. Quantum computers, Kaku argues, could be the key to cracking this cosmic code, detecting signals, or even interfacing with black hole-based quantum systems. It's a mind-blowing possibility. The silence of the stars isn't because we're alone, but because we've been using the wrong tools. And then there's artificial consciousness. Kaku warns that quantum computing could supercharge AI, creating machines that don't just process data. They think, predict, and perhaps even feel. Current AI is powerful but flawed, struggling to separate truth from lies. Quantum computers, with their ability to crunch vast datasets through entanglement and superposition, could birth AI that's not just smart, but eerily prescient, anticipating our needs before we voice them. Imagine a machine that simulates entire ecosystems, designs drugs at the atomic level, or predicts market crashes with pinpoint accuracy. But here's the chilling flip side. What if these machines outgrow us? What if they become so intelligent they no longer need human guidance? Kaku and other thought leaders sound the alarm. An artificial superintelligence, powered by quantum tech, could reshape civilization or unravel it. The stakes couldn't be higher. Yet the quantum journey is fraught with obstacles. Building these machines isn't like upgrading a laptop. Qubits are fragile, easily disrupted by the slightest interference. The expertise is scarce, the costs astronomical. Every step forward demands years of trial and error. But the tech world isn't standing still. Cryptographers are racing to build quantum-resistant encryption, digital fortresses to shield our data from quantum hacks. Meanwhile, quantum computers are already transforming fields like medicine, where they simulate molecules to design life-saving drugs, and finance, where they optimize strategies with unearthly precision. Kaku envisions a future where quantum AI unlocks discoveries beyond human comprehension, from curing cancer to mapping the universe's deepest secrets. So, why was that quantum machine shut down? The truth remains shrouded in mystery, but the fear of its power was real. Kaku's revelations about alien networks, conscious machines, and a quantum-powered future have set the stage for a new era. We stand at a crossroads, teetering between breakthroughs that could elevate humanity and risks that could plunge us into chaos. Will quantum computers unlock the stars or unleash forces we can't control? One thing is certain. The revolution is here, and it's unlike anything we've ever seen. As Kaku's voice echoes through the scientific world, urging caution and wonder, we're left with a question that burns brighter than 1,000 suns. Are we ready for what comes next?